Hello everyone. Today we're going to take a look at Redux in all its glory. That is, it's not just Redux. We'll also cover Redux, Redux Thunk, Redux Saga, and Redux Toolkit. How does all of this work? Why do we need it? Where do we start? Let's begin with the question, why do we even need Redux? As you can see, I've already launched the application here. I generated it using Vite. There's also TypeScript here, but we'll get to that a bit later. So where do we start? Let's start by not touching this for now. Let's begin with the question, why do we even need Redux in general? Let me explain what's shown here. What's the point? When we got our modular components, our modular applications, passing state from one component to another became rather inconvenient. That is, we take our component and pass things down or up. This isn't very convenient. Again, if there's a different level of nesting or if components are located in completely different places, working this way is absolutely inconvenient. That's why Redux is needed. And in general, the front end needs some kind of unified storage in different frameworks. It's done differently. We'll be talking about React. In React, we have Redux now. Redux is a centralized store where, roughly speaking, we put our data. Let's say this is our component 3. Suppose in this component, we fetch our post as we made a request to get the post, and in one of these components, we need to display them. So here we made the request just as an example. And instead of passing data from one component to another, we use Redux. In other words, we don't deal with so-called prop drilling. We simply fetch the data, receive it, and then manipulate it as needed. Now let's take a look at the adjacent diagram. What do we see here? Here we see the Flux architecture. What is Flux architecture? Well, basically it's about how an action changes our store and a new view appears. And it forms this kind of closed loop. There's even a somewhat provocative question that sometimes comes up in front-end interviews here. What's the difference between Flux and Redux? In fact, there's no difference because Redux is essentially Flux architecture. What's its essence? We have some action. For example, in our view, we trigger our handler to request posts. We dispatch a specific action. The action goes to the dispatcher. The dispatcher takes it and then performs certain actions, makes requests, and so on. After we complete the request, our changes go into the store. That is, when we directly modify our storage, as soon as the changes appear in the store, we poll each of our views and our changes show up. Before you continue watching, I highly recommend you check the description, go to my Telegram channel and subscribe, because the newest, most up-to-date and first-hand information is released there. There, I conduct polls to decide which technology we will review next. There will also be contests for free consultations and so on. There will be lots of new perks, so go to my Telegram channel and subscribe. And accordingly, in this closed loop, we change something in the view, the changes go to the dispatcher, then to the store, back to the view, and so on. It's basically a closed cycle like that. So essentially, the Flux architecture is exactly what our Redux is. We've covered that. Now let's move directly to the project. To start with, I generated it here using Vite. There's a single component here. I'll explain what that is in a moment. And there are a few components for our stores. For convenience, I made separate folders for each approach. But what's the point? What do we see here? Here we see our app component. Let's move to the async store, since that's the first one. We'll start with the index.ts file. Well, different developers organize all this in different ways. I did it in a simple way. Maybe it's even a bit rough, but that's how it is. Let's start with the fact that nowadays people usually write configure store. And when you come across create store that's already outdated, it's rarely used and generally not used anymore. Now, people use configure store from Redux Toolkit, and overall, it's not really worth talking about plain Redux anymore. It's always Redux Toolkit now, or things like RTK query and so on. But for RTK query, that would even require a separate video. So what is configure store? Well, configure store or create store, it doesn't matter. The point is that this is our entry point to our store. Here we specify reducers, middleware, and some other parameters, but the main ones are these two, reducers and middleware. You can check the documentation for the rest. Let's start with reducers. They define how we store our data. And middleware are our intermediate values between our action, that is the execution of our action. Let's move on to the reducer and see what it looks like. A reducer is a function that first takes in what? Our state, that is our storage, how the data is stored there, and an action that is the change to our state, how we are going to make that change. An action has a type of change and also a payload, people call it differently, but the point is that the second parameter is usually the data that we use to make changes in our store. We see that the function looks like this. Some people write it using if, but it's better and more convenient to use switch case, because you can go through and specify the changes, that is, for each type of change, what changes happen to our store, It's also important to know that Redux and general Redux approaches Redux Toolkit, RTK query characterized by the fact that we work in an immutable format. What is immutability? Mutability means that we can mutate our changes, that is, when we have some object, and we can add some fields or assign a new field or value without changing the reference to our object. So we know that objects and arrays are all reference types of data, and when we overwrite our values, we overwrite our reference. But the point is, with Redux, it doesn't work that way. Redux is immutable, meaning that when we interact with Redux, any change to a parameter in our store, in our state, no matter how it happens, occurs in such a way that we change the entire object each time. To reference, and in the case of MobX, we could even make a separate video about comparing MobX with Redux. There, it works on the principle that we modify things directly. In other words, in that format, we don't generate a new reference every time. We see that we have our reducer right now. We're just looking at count. Next, here I used S. It's better not to do it this way because that's a hard typecasting. And here we've defined the reducer, counter reducer. How are we going to change our data? And we have our reducer. So how do we actually change our data? We add our value, subtract our value, and in the end return our state. We see that in order to run our reducer, we need to dispatch some action. Let's go down to the action, count action. There are a lot of types here. These are the types of our changes. That is, this is increment, decrement. Well, I'm only doing increment. Then there's the typing of our store, and here is our action itself. Increment, decrement, we take our parameter number and modify it. That is, we simply pass the payload depending on whether our type is increment or decrement. In the reducer, we can already, roughly speaking, take action. If it's increment, we add our value. If it's decrement, we subtract our value. And in the helpers, we have additional typing specified here, and then we have two ways to work with our store. We have the option, and in general, the point is that even without TypeScript, we can work either through the selector and use dispatch, or we can work using the connect function. This is the old way of working with Redux. We'll also look at it now, but first let's start with our selector and useDispatch. The idea is that when we use a selector, as I think all of you know, we first receive the state, then work with it, and extract our parameters. And for our selector to know what we're working with, we need to add some extra typing. We can see that when we work with state through useSelector, we can specify state and then drill down to what? To exactly what we need. For example, here we've accessed our account. All right, good. Helpers. We can see that it's exactly the same thing with dispatch. To make it convenient to work with TypeScript so that we have handy, so that we have convenient suggestions, it's also better to add extra typing to it. All right, I fixed the error a bit. I just imported the solution from RTK there. It was a bit incorrect before. Now we can see that our changes happen every time we click on our count. Our dispatch picks up our action, our increment action. It has a type. As the type is increment, we can see that our increment action also has a payload. We pass the value 2 as the payload. Every time we call our useDispatch, our changes are sent to our reducer, our count reducer. We check that our action has the type increment. We see that its type is increment, so we proceed to update our store. We take our count, which we had in our store overall, take the previous count, and add the additional value. Since this is a primitive, in other words, a number of the reference will change anyway. So this is how we work with our store. Now let's take a look at asynchronous solutions and see how they work. Because when we work with synchronous things, we need a small intermediary layer. And that's exactly what our Thunk, Redux Thunk is. It's the intermediary that allows us to work with our actions asynchronously. So when we make a request, we need to wait for it to complete and then give the opportunity to update our store. So what does our Thunk do? It's like a wrapper. It acts as an intermediary. It takes our action, resolves it, takes the resulting value, and puts it into dispatch. This is how we can update our store. To make it clearer, I wrote a small example of our middleware. This is a logger, which does what? The first argument it receives is our store. From there, we extract dispatch. From dispatch, we can then extract next. In other words, this determines what we will do next. The second parameter, well, not exactly the second parameter, but in our nested function, with this function, we receive our action. The action contains our data, meaning what we are storing. We have our payload, our type. We can resolve all of this somehow. We can also perform some additional side effects, whatever we want. Speaking of side effects, the next method with sagas will cover that. But the point is that we've done something. After that, we return our next. In other words, we simply continue making our changes and move on. And after that, our changes from our asynchronous variant appear in our store, and we can see everything nicely. Now let's take a look at how this works in the case of the asynchronous format. We have our reducer for posts. Here we have one type load, let's say for loading. We call our action with the type load. Our values are received by the reducer, and we update our posts. You can see that we have a separate reducer specifically for our posts. We put it here and wait for our changes. Well, we don't actually wait for our changes, we just write them out. In the actions, we have a similar type of interaction. We have our types, for example, the load type. Next is our post type, then the type of our state. And then we have the interface of our, well, roughly speaking, our action. It's the same here. Here we have the payload type. We can see that we have our usual action in which we expect our data, which consists of posts, basically an array of posts, and changes. Here is where we actually perform our load. Now let's move on to the asynchronous format. In the synchronous format, we have our function, and inside it, there's another function, which is asynchronous. In this synchronous function, I wrote a small middleware in the form of fetching posts. We fetch the posts and trigger our action through the internal dispatch, and then call the update of our store. So this Thunk is responsible for taking our nested function, resolving it since it's synchronous, and passing the value to our store that is updating our store, and this load triggers the updates. If we go to our app TSX, we can see what exactly is happening here from dispatch. So from dispatch get post, we're simply requesting the posts. Next, we use our useSelect to get the posts and display their ID and title. Let's see how this looks now. Let's refresh the post. We can see that the posts have loaded. This happens in a synchronous format. In other words, we trigger our action, useDispatch, launch get post runs, and since we have our Thunk, which is our middleware, it takes this function, resolves it, and because it's synchronous, it allows us to run our dispatch inside this function, which then triggers our load. Additionally, this load takes our changes with the type load and passes them to the reducer. In the reducer, we catch our load change and update our store, meaning we update our posts. After that, we can see our changes right here. That's an example of how it works. Now let's take a look at another cool way to work with our store without useSelect or useDispatch. This is the old way, and nobody really uses it anymore. I'm mentioning this solely to broaden your perspective, because not everyone talks about it. And there are legacy projects where you might encounter this as well. Working with the store using an additional function called connect, which operates based on the principle of correlation. We see that we have the same app. I'm going to rewrite it a bit now. We see this connect function, which works on the principle of correlation. Here we have two actually. 4 parameters. I've written 2 here, but I'll add all 4 later. You'll see what it looks like. And for useSelect, by the way, it's not just 1 parameter, but 2. I'll explain how this works now. With connect, we have map state to props and map dispatch to props. So essentially, we're working with props. We pass our state into props, and we pass our dispatch into props. You can see that here we're passing our function, which resolves and returns our object from our state directly from our store. Here we have our function that works with dispatch, which also provides our object with the changes to our store, such as increment, load, and so on. Now let's take a look at some additional parameters. The third parameter is mergeProps, a function that allows us to merge our props. Check the code, open console, and see we have an object. The object is an object from the props. That is, I have displayed our props. What's the point? That in the props we receive our account, increment, load, post. These are our props that we get using map state to props and map dispatch to props. And that's exactly what the third parameter is for, so that we can, for example, get our state. We can get our dispatch, right? Dispatch our parameters and return, for example, only the state. By returning only the state, we'll now see the difference. We'll see that here we only have count and post. In other words, mergeProps is responsible for how we merge our posts, or rather our props, with each other. If we only want dispatch, for example, we just set dispatch. And as the fourth parameter, we have this big object, which allows us to specify additional parameters. So when we change our state, we can track our changes, that is the previous value, the current value, allow or disallow changes, compare them. For example, let's call this function of vars and have it return true. Let's see how this will look. We specified whether our states, that is the previous and current ones, are the same. Now let's make some changes. For example, we see that no changes are happening. Why? Every time we change our state, we compare the previous value and the current one, and since they are equal, we don't make any changes. Now let's set it to false and see what happens according to the storm principle. Well, everything's okay. And why am I telling you this? Why is this important? The point eyes, or rather. Even here, we can take a look. Some people, when they receive the state, write a function like this, for example, a filter or something, maybe with a count or with posts. Let's try to write one, some kind of filter or something else. For example, here we write a filter by some value and return it. You absolutely must not do this at the root. Why? Every time our state changes, we dispatch. When the store changes, we poll each of our components for changes. That is, our reference either changed or didn't change. Since each time we return an object, every time we call our filter, changes occur. In other words, every time we return a new object, even if we consider the case where we make a change but don't actually do anything extra there. For example, we still have posts with IDs greater than 50, just like before, but the point is that we are returning different references. That's why these parameter there are actually, many of them gives us the ability to compare how changes were made. The changes were made under deep equal. In other words, we will compare our deep reference, deep change. There are different ways to do this. But the point is that every time we make changes, the changes are compared using shallow equal. Shallow equal means that changes are compared by reference, whether the reference has changed or not. If the reference has changed, then our component should update. If it hasn't changed, then accordingly, the component does not update. So basically, if we change, say, some other component somewhere else in our application, this actually triggers an update in the current component as well, because the filter gives us a new reference to our post. That's why you absolutely shouldn't do it this way. But if you do, of course, you can handle this situation here, maybe write something extra, but fundamentally, it's not the right approach. I'll show you a different way to handle such cases a bit later. All right, everything with connect is outdated. So what should we do with useSelect? Let's comment it out. Let's go back to our useSelect and uncomment it. It's the same here, except we have an additional second parameter, the same quality function. Here we have our prefprops next, and let's say we'll call it here. So return. True. This is also equal to, let's say, we log prev and next in the console, save it, go back, refresh, and we see that we have 0.2, 0.4, 0.6, 0.8. So in fact, they are different. But since we set it to true, they are considered equal and no changes occur. Let's save. We see that changes are happening. We had Thunk, and Thunk is an intermediate value that allows us to work on the principle that we resolve our asynchronous event. So what is Saga? Saga is a subscriber to our changes. That is, for example, we have some change, and we called our action, say, on load. We subscribe to the load action and wait every time we call our load. What do we need to do? We need to make an additional request to the server to fetch the posts. We fetched the posts, and what else did we do? We triggered another additional action to add these posts to the database. So the principle is just as simple, but there are many different aspects with sagas, many additional effects. By effects, we mean how we work all, put, and so on. There are take, every, join, fork, spawn, and so on. This could even be covered in a separate video or in my Telegram channel in the description. I'll probably post the entire list of possible effects available in Saga. But the principle is simple. As I explained, we have an action and we have a reducer. Now let's look at the sequence. Every time we click to change our, let's say we change something, we call our useDispatch. Increment works just as simply. That is, since this is a synchronous option, our increment calls the increment in our reducer and the changes happen. In the case where we are working with posts, how does it work? We go to the tsx file and call our load. Load is just our regular yes regular action that simply dispatches the load type, but we use sagas. Sagas are written separately. First, we need to create them. Create a Saga middleware, which is also a middleware that lets us set up subscriptions. We add our middleware and run our root Saga. So what does our root Saga do? Right. The Saga is responsible for intercepting our action every time, calling our additional fetch post and invoking call here. In other words, we have this special additional effect that allows us to use our asynchronous functions and so on. This is convenient when we are debugging or doing extra checks and so on. Sagas have extensive support for that. And then there's an additional effect for updating our data. So we have our extra action for set post, and we simply pass our values here, our payload and our pool, which is basically our dispatch that applies our changes to the store. Now you can see exactly how our sagas work based on the principle of generators and our yield function. A generator is, roughly speaking, a function that can pause and resume execution. This is convenient. A generator acts as a factory for iterators. So in fact, every time we call our generator, we get an iterator that we can iterate over. This is convenient. And in roughly this way, we can work with our store asynchronously. These are sagas and thunks. The idea is that with a saga, we subscribe to events. It's a somewhat more complex format because there are many effects, a lot you need to know, how to parallelize things, and various other aspects. So not everyone uses it. With Thunks, it's simpler because it's just a handler. In other words, it simply processes, or rather wraps our asynchronous event, resolves it, and sends our changes to the store. So we've generally looked at the approach with our store in the context of Redux, usually with Redux Saga and Redux Thunk. Now we need to take a look at Redux Toolkit. When we usually write our store, having to create actions reducers and put everything together every time is not very convenient. It's a lot of code, and nobody likes a lot of code. That's why Redux Toolkit appeared. Redux Toolkit simplifies things several times over. Overall, nothing really changes for us. Here we have a config cursor. What I did here is simply export the entire slice. That's why I call the reducer from the slice a slice. It's a key concept in Redux Toolkit because they're usually called slices. It's a large combination of reducers, actions, and other things. We'll take a look at this now. Saga hasn't gone anywhere. You can still use sagas with this, as far as I remember. So there are no restrictions. There is just a more convenient way to interact. The helpers are the same. Overall, nothing has really changed. But with slices, we can see here that we just have post and count. Let's go to posts. We can see here that, well, you can separate all of this out, which is what people usually do. I just put it all in one place, so it would be easier to look at. Again, we have our posts, our post type. We have the type of our state, and we have, well, not the type, but our actual state. We'll also look at our asynchronous interactions, and then our slice we create a create slice. Here we specify what is going to be called and how we can refer to it. Our reducer values, that is, how we will get and modify our store, and so on. We'll look at extra reducers for synchronous events a little later. And once we've created our slice, we simply export it. There are already many different attributes available here that we can access. Actions, case reducers, get initial state, name, reducers these, allow us to get our reducer actions and the actions that are generated in the reducer. So everything here is convenient. We get our name, initial state, case reducers. This is how we can further extend our slice. Now we just go and tweak it a little. All right. Now I've switched everything to RTK. Let's see if everything's working correctly. The count is working. The post is also happening. Let's look again at the same chain, the point. So when we click, we get an increment. Let's go to the slice. What do we have here? We just have our count here, and here's our value. And here we create the slice. In the slice, we set the name how we refer to it. Next is the initial state. That is, our initial value is account 0, and the reducer or reducer is increment. So this is how we change our value, and here are extra reducers. But since we're working in a synchronous format, I didn't even touch them. To get our action, to obtain the action, it's simple here, just this structuring. We get increment from the actions, and then we can call it wherever it's convenient for us. So we call dispatch, call increment, and here our increment is just like a regular function. It's all convenient and it's much less code than if we were writing with plain Redux. In the case where we're working with an asynchronous format, for post we have create async thunk. This acts as a kind of middleware that allows us to create our asynchronous interactions. Here we simply specify our name. Here's our function. Here we can pass in some additional parameters, and here in the thunk we can make some extra calls if needed. Here we can define how we want to handle our asynchronous interactions. We can cancel it, trigger something extra, call our state, and so on. As the first parameter, we can pass in some value. That is, let's say if there is some kind of fetch post, here we can pass on the ID and call our synchronous interaction. The API post then moves into extra reducers. Here we work according to an interesting principle. We take our builder and use it to rewrite our changes. That is, our fetch post has several states, such as fulfilled. If everything is completed, that's great. There's pending when we're waiting, and rejected. So each time we click on our request write on our post request, we can immediately access our store and set the value to indicate that our posts are loading. That is, we specify fetch posts, pending, set a loading flag, and trigger our value here. So we can trigger our loading, and then when our fetch posts is fulfilled and our posts are displayed, we simply set state posts equal to action, payload here. Let's write our builder. All right. This is the case for fetch posts, let's say, when it's pending. We specify the change in our initial state. What else should there be? The loading flag is initially set to false. Here we'll define our loading flag. All right, we've set it uploading will be a Boolean. Next, here we specify the change to the state, the action. We've defined the function and returned it as a function. Now let's go to our state. We just set loading like this. So the loading happens right here. When we get the state, loading is false. To start, we just need to specify. If we have a post, then it will simply be post. It's a bit messy, but it's quick. A post with loading. For example, if it's loading, what do we call? We'll call a div with loading. Okay, all right. Now we'll move on. Now we'll set the word FreeGA load post. We can see that loading is happening. Only after that do our posts appear. This is the principle we can use to work with our editor. There are many different possibilities, many additional aspects. There, with Redux Toolkit, there's RTK query, which allows us to interact with the request and further cache it. In other words, we don't have to call it, and it also simplifies our interaction with requests in general. But that's a topic for a separate video, specifically about Redux Toolkit in depth plus Redux Toolkit query. There's also another point to mention. When we work with useSelector, as I said, if we return a new reference every time, we will cause our component to re-render every time any part of the state changes. So it's better not to do it that way. But sometimes there's a need, for example, when we're working with posts, to maybe add some kind of filter here. How do we work with this? To implement this kind of behavior, Redux Toolkit provides something called createSelector. Here we can define selectors. The first argument we pass is the selector, which determines how we retrieve our value, how we extract the values, for example. The second parameter can be a function. So it will work something like this. For example, we get our function here, which we can interact with. Let's say here we specify a item id. Now we can tie it to this item id, apply a filter, and return our value. So if we need to work with, say, some filter map or other things to pass our value, we use createSelector. Also, createSelector gives us the ability to cache our value. That's basically it. Subscribe to the channel, subscribe to my Telegram channel, and leave a like. Let's stay in touch.